So red has the lowest frequency. Frequency is C over lambda. So frequency wise, red is lowest. That means red has the lowest energy. Green has middle and blue has most. So now look at this picture again. Do you see a correlation? What can you tell me? Low frequency light, medium frequency light, green, highest frequency light, blue, purple, whatever you may want to call it. They're close enough. So is the blue photon coming out, is that going to be the fastest? Will it have the highest kinetic energy? Will the green one be lower? And will it have lower kinetic energy? Excellent. Now, what about the red? There is no electron that's emitted. That's confusing. What they tried to do was they tried to increase the intensity, because that's what you would think, right? If you all that means is that intensity needs to be increased. So if I keep increasing the intensity of red, of course it should start emitting, right? But it didn't. Weird. And I'll show you how that is done. So if you go to this sim that's here, this is a simulation of this experiment. So can everybody click on that or just watch the board? It's either one. I think I can do this here, but if you guys want to do it, bring it up. Yeah, it takes a little time for it to upload, but it'll upload. And then you can play around with it. So basically what you can do is you can start intensity, making it, wait, why is it? So photon intensities, you can make it go, and you can see that the electrons are being emitted. And you can change the color of your light. Look what happens when I change it to green. What happens when I change it to green, guys? What if I change it to yellow? Any electrons coming out? What about red? I can increase the intensity as much as I want. Any electrons coming out? That's weird. Wouldn't you assume that if I just throw a bunch of photons on it, shouldn't they just start ejecting electrons? But notice what happens when I decrease the intensity to maybe like 50%. Okay, maybe 49%. Okay, nothing's coming out, right? Nothing, nothing, nothing. I'm just changing the color of light. Nothing. I'm almost green. Something started happening. Okay, what do you notice about these electrons that are coming out? They're not moving very fast. Okay, if I change the color more, oh, so if I change the intensity now that I know that electrons are coming out, what do you think will happen? Will it? Okay. So I'm going to make my intensity go back to 50% if I can. 50%-ish. And if I'm going to change this back to, say, yellow, nothing's happening. That's weird. Even with the most, so this is something classical physics could not explain. They couldn't explain it. What is going on? Don't you think if I just increase the intensity of my light, shouldn't I just be able to just see electrons coming out? Like that's what classical physics says, right? All I have to do is apply more force to something, it'll go faster. But that's not what they were observing. That was very weird at the time. So let's draw the experimental setup. And I know that there is a battery here. I want to show you something. This, let me just do this. So that we'll see a lot of electrons coming out. So now I'm in the purple range, right? And do you notice that the electrons are actually getting faster? They're speeding, right? From before when they was green, and now they're purple. This animation is so cool because you know what you could do? You could also look at the different metals. You could look at what will happen if you have platinum there. You could look at if you have copper there. Oh, copper. Even at the same intensity and the same wavelength, nothing gets emitted. If you have zinc, oh, I didn't realize zinc was bad too. Oh, I don't, they say you have to guess which one this is. So sodium is good. So let's stick with sodium. Okay, you can also do, here, you could do, count the number of photons instead that are actually being hit. You can increase the number of photons that are being hit. You're hitting it with. You can decrease the number of photons. Okay. Do you notice when I don't ask for the number of photons, it's just light going in. It's actually physically light going in. And so that's what they were doing. They were throwing light at the metal and seeing what was happening. Just the fact that this was there was Einstein's genius.